Yeah, so I'm really excited to be here. Thanks to the organizers, really great group of people. And yes, I'm a social psychologist by training, and I want to talk to you a little bit about this framework that I've been thinking about over the past couple years. And the way that I kind of got started thinking about algorithm-mediated social learning was by thinking about a broader question, which is how social media fits into the trajectory we see with traditional media when it comes specifically to increasing polarization in the US and doing things like increasing moralization and outrage stoking. So some of you might recognize, obviously this is Ronald Reagan on the left. How many people know who that is? A couple people, yes. This is Jerry Falwell, who in the 70s and the 80s, he was basically the dominant evangelical Christian leader. And growing up in the South, his influence was felt very heavily even as a kid. And so basically, he had the third biggest following in terms of TV network viewership. He had 20 million people viewing his TV show on a weekly basis. And what was the message that he was sending people? Well, it was specifically one of outrage stoking and moralization, and it was done so in an attempt to organize the political right against the political left. And so he famously said in the speech, "We're fighting a holy war. What's happened to America is that the wicked are bearing rule. We have to lead the nation back to the moral stance that made America great." You might recognize some of that rhetoric in some previous presidents. And so, what I want to think about today again is sorry, I went surfing and swallowed a lot of salt water yesterday. What is the role that social media plays in this kind of process? And what I argue is that on one hand, it's very similar. You have, oh yes. Sorry. On one hand, it's very similar. You have political elites and hyper-partisan news organizations who have asymmetric control of information on the platforms, and they're sending these messages of outrage stoking and moralization, and people are perceiving that. But also on social media, I argue, there's something really unique going on compared to traditional media. So you have what this term I like that's come out of the computer interaction literature, human-computer interaction literature, is one of collaborative work. So social media is a context of collaborative work. That's what distinguishes it from traditional media. What does that mean? Well, it means the information context is participatory. So rather than just having information broadcast to you from a central figure, you also see your social group interacting with that information. So maybe they share it. Maybe they put their own commentary on top of it. And when that happens, outrage and moralization that might be really getting seeded from, say, political elites, well, that becomes more of a social reality than in the case of traditional media because, again, you have social group members actively interacting with that content. And so all the social scientists in the room, you might think, okay, well, this is important because social norms, which can get formed from this social interaction, are much more influential than mere information exposure. And so the thing that I'll be focusing on today is the fact that it's even more complicated in the context of social media because this social reality that's getting formed, well, actually, it's shaped heavily by content algorithms because this information, it's not just information, it's social information, it's getting filtered and it's influenced by the algorithms. So I want to kind of give you some theoretical background. And mostly what I'll be doing today is just presenting this conceptual model. And then I'll present like one slide of data because it's work in progress. But I'll kind of give you some background about what I've been calling algorithm-mediated social learning. And it starts with this observation. A lot of us are social psychologists in here, so this is kind of a duh statement. But humans are very unique in how prodigious of a social learner we are. So we learn through direct feedback, we learn through trial and error, we learn through people telling us things, and even just observing people. That's one of the primary ways that we learn about social norms, what we ought and ought not to be doing. But it turns out that our social learning is actually very biased. And it's biased, though, in an adaptive way that actually helps us learn efficiently from other people. So, for instance, we have context biases. We tend to be prone to copying prestigious individuals. We are prone to copying in-group members. And it's been argued in the cultural evolution literature that this actually makes us more efficient in learning. So take a prestigious individual. Prestige is typically correlated with success. And so if you copy successful individuals, you're learning more efficiently. in-group members, they're more relevant to your immediate social environment. There's also content biases. We're biased to learn from and attend to emotional information, moralized information. Why is this adaptive? Because it's typically rare in our social environment, and there's several studies and evolutionary models that show this can actually aid in cooperation and collective problem solving if we're detecting things like cheaters early on and curbing them. So the function of social learning biases arguably is to promote collective problem solving and cooperation. That's one way to summarize it. Now let's contrast this with the function of a traditional social media content algorithm. Now this is a little oversimplified, but obviously one big component of it is of algorithms are to capture attention and maximize engagement on platforms. And so right off the bat, I like to think about this as a problem of what I've referred to as functional misalignment. Why functional? Because you can very specifically point to functions that really are not lining up with one another. They're designed to do different things, and of course, that might create some issues. Now, if you've been paying attention, you might be able to predict what are the things that are most likely to capture our attention and to maximize engagement. Well, it turns out it actually is the things we are biased to learn from. And so there's about a decade or so of work that has now been documenting in various forms through experiments, through observational field studies, including some of my work, that actually the things that draw a lot of engagement on social media are the very things that are corresponding to these social learning biases. And the way I like to summarize this is prime information. So prestigious, in-group, moralized, emotional information. These are the things that are systematically amplified by content algorithms on certain platforms, and they're also the things that, and that's a side effect of the fact that we're biased already to learn from them. So it's not that content algorithms are designed to amplify prime information, but they do as a side effect of other goals that they have. And now I think I can do a summary of this conceptual model and talk a little bit about why should we care about the fact that prime information tends to get amplified. So just to summarize again, we're biased to attend to prime information. Content algorithms amplify this information as a result. And then you get this really interesting thing that I'm most excited about these days, which is the crux of algorithm-mediated social learning. Not only are algorithms learning from human social learning biases, but they're amplifying content, which again includes social information, because it's not just information they're upranking, for example, it's things coming from our social network. Now we start to learn and our norms get shaped by what the algorithms are upranking, and you get this feedback loop of human and machine learning. And what this tends to do, I've shown in some previous work, is it overrepresents prime information in the information ecosystem. And that actually has really important consequences, because in offline social networks, or at least in classic small group settings, prime information is typically pretty rare. And that's why it's adaptive to be hyper-focused on it, because it can give you a shortcut to learn from things, for example, catching cheaters. But if it gets actually overrepresented in your information environment, now instead of detecting cheaters and promoting cooperation, for example, with moralized and emotional information, now it leads to conflict. And I also have some recent work suggesting that also amplifies misinformation. So you get these outcomes that come through this process. And by the way, I have like 60 slides of data like after my talk if we have time to get into it, so I can always go into them. But for today, I want to focus on a new study I've been trying to do to get around some limitations of my own previous research, which has been very observational. Even though there have been some field studies, it's really hard to disentangle the effects of human social learning biases and algorithms, because people come to the platform with years of history on the platform. So if you do a study now, it's hard to control for the different effects there. And also, as researchers, even when we collaborate with social media companies, we don't always have control over the algorithms. So I want to tell you about this paradigm that I've been working on, and it's using this, paradigm called Your Feed, which if any of you have collaborated with MIT Media Lab, it's something they developed in the past couple years. So basically what we can do in this paradigm is you can assign participants to different conditions. You can manipulate the content, in other words, for example, like tweets or social media messages that they're going to see in a feed that's controlled by an algorithm. And the important thing is you can actually control the algorithm behavior, and you can manipulate that, and you know exactly what's going on there. And then you can also populate and measure engagement. So just to show you an example of what this looks like, this is the most basic bare bones case, but let's say a participant is just scrolling through a feed. They can just interact with it. They can like things, share things, they can scroll, et cetera. And the really important thing for the framework that I presented is this paradigm measures dwell time, just like social media companies do. So we know how long participants are dwelling on each stimulus, and it's measuring that automatically without the participant being necessarily aware of it. So in this first study that I want to describe quickly, we developed and validated a large stimulus set that varied systematically on these prime dimensions. And I can talk a little bit more in the Q&A if people are curious, but it was extensively pilot tested. And for the first pass, we're actually manipulating content on things like in-group praise, out-group blame, because those are categories that tend to vary morality, emotion, and in-group all together at the same time. So it's kind of like a just blunt hammer at this point, but we're getting more sophisticated as we move on. And as I mentioned, it measures dwell time and engagement. And then in this first experimental phase, we are taking participants and just having them scroll through the data. So these are participants with no background, obviously, on the platform. And then the algorithm is literally just getting trained on what they dwell on. And so you have an algorithm that doesn't know anything about these participants. Then they scroll through it, and then basically we have an experimental phase, which unfortunately is not done, so I'm not going to talk about this yet. But we basically can randomly assign participants to this attention-trained algorithm, or a control, which is, for example, random assortment of messages from our database. And then we can see how does it influence their perception of social norms and their engagement. But the first thing that I've found already, this is, again, very early. Actually, this was sent to me about 2 days ago. We can see, and these dwell time data tend to be really noisy. We're looking into the best ways to transform them, but all the pattern stays the same so far. So right off the bat, we see that the prime dimension, so in-group praise and out-group blame, they're getting significantly longer dwell time just in a first pass when we're just showing about 500 participants across the political spectrum these types of messages. So this is directly predicted from the model, so it's a good first pass, and then we'll see what happens when we build out more participants and more features. So as a summary, algorithm-mediated social learning leads to an overrepresentation of prime information. I have some other data supporting this claim. And when it is overrepresented, this leads to social misperceptions, including misperceptions of norms and polarization. I also have a study there. And I just want to take the final minute to say, I've been thinking a lot about, well, how do we actually make social learning more accurate in the context of algorithm-mediated social learning? I think you could do one of these two things. I would love to talk to people about B. It's not something that I've successfully been able to come up with a good idea yet, but I have been thinking a lot about A, and obviously for this group, I'd love to talk about that more too. So I know I must be running out of time, so I want to kind of gloss over the fact that it's actually very unclear what the goal is when you're dealing with like outrage and polarization compared to misinformation where you just want to get rid of it, but I'm going to skip through that. So here's something I think you shouldn't do. Get rid of prime information. Actually, outrage and polarization can serve important societal functions sometimes. And so it's unclear that you just want to get rid of it because, for example, outrage can challenge the status quo and it can motivate collective action. So actually, I don't think that's what you should do. Wholesale diversification, which is actually talked about a lot in computer science studies I've read, that seems like a terrible idea in the context of politics. That could lead to consequences where you have like a political moderate who's exposed to far-right content, and who knows what could happen there. So what I've been thinking about a lot is something I call bounded diversification. And the idea is that you do want to diversify content by penalizing prime information because we know we're already biased to learn from it, but you're going to do it only in the space of content that tends to already be engaging. And I think that serves two goals. First of all, it can be things that keep participants or users on the platform, so this isn't like, okay, now they lose interest and leave the platform. But also, there's other things that capture our attention, like surprise, like positive emotions, that could then be, as a result, upranked. And so you're really not getting rid of it, you're just balancing the information ecosystem more, given that we have these psychological biases towards certain types of information. And that's all I have. I want to thank my collaborators who have been involved in the empirical component, some of which I didn't present, and also this framework I recently published in a paper, which you can get from the QR code. Thank you.